Hi, my name is Michal Gala, and I am a junior in chemical engineering doing research in the Theorem group on electrochemical ammonia production. The reason this is important because ammonia goes into all agricultural production in the world in the form of fertilizer. It has fueled the steady growth of the world population over the last 100 years, but the method we currently have available of producing it has a very large capital cost, upwards of $1 billion per single plant, and carries a proportional penalty in terms of CO2 emissions. This is why we are trying to utilize lithium's natural reactivity towards gaseous nitrogen to produce ammonia at ambient temperature and pressure with oxygen as the only byproduct of the reaction. We do so by producing lithium nitride from metallic lithium and nitrogen, and then hydrolyzing this compound, forming ammonia, which has been released and quantified, and lithium ions, which are then electrochemically replated as lithium metal. This process requires a hydrogen carrier, so a proton source, and this is where my project comes in. I am looking at different compounds that can be used for that purpose and trying to find trends between them. We identified 3 groups of compounds. Some of them are active in the process and produce ammonia as is expected and reported in previous literature, but some of them do not do that. We divide them into 2 categories, the inactive and the hyperactive sources. Inactive sources in some way do not seem to activate lithium towards reaction with nitrogen, so the nitridation reaction, and do not give any yield of ammonia produced. And we are now doing research trying to explain why that is, because it's a very surprising result, because lithium reacts with nitrogen by itself. It shouldn't need to be activated towards that. Another interesting result we got is the specific characteristics of the active proton sources. And it turns out that some of them are not exactly the same as reported in literature, which means that very small structural changes to the molecules cause a big difference in their reactivity in this system. Doing that allowed us to optimize ammonia production as a function of concentration and choice of proton source, leading to significant improvements in Faradaic efficiencies of produced ammonia, using especially N-butanol as our proton source. Thank you.